Welcome everybody to this great invite where we actually have Joe Justice to explain to us all the cool stuff he did at Tesla and for all of us to be inspired by what he is going to explain to us. We're here with two groups. On the one hand, this is the kickoff of the hardware community. On the other hand, I also have my colleague Rimi here, who has his own cool group that is joining us today. Just a short introduction. My name is Mirelle Vink. I am a transformation consultant for Prowareness, and I am the kickoff person for the hardware community. And then over to Rini.
Yeah, I'm Rini Vasoli. I'm here on behalf of the Thought Leaders Network, but we'll deal with it later. I have the honor to introduce our special guest of today, Joe Justice. And I think it's more than 10 years ago, I saw the first talk of Joe about wiki speed, where he was able to translate concepts from agile ways of working, lean into car manufacturing, really changing the world. In fact, changing even the possibility to do simulations for crash testing for road safety certification. But that's not the topic for today, because today Joe has joined last year at Tesla, and I've seen two talks about this. And to be honest, in the last year, the things that inspired me the most and really got me out of my feet when I heard this, I said, what is this? Were these talks. So I'm really proud that Joe is joining us today to share his knowledge and experience. There's also plenty of time for questions, if I understood. So Joe, take it away, take a lead. And I'm really happy to hear everything you have to say. And I have plenty of questions, but we'll see how it goes. Joe, please.
You are the best. You are actually the best. Thank you so much. To set the stage honestly, I'm from a small farming town in a place called Indiana in the middle of the United States. So I'm the definition of an ordinary person. I mean, Utrecht looks like a big city compared to where I'm from. And I had a silly idea to make a car company, and I only knew Agile. And so it happened to be an Agile car company because I didn't know any other way. And it worked on a small scale. It worked. We set 4 world records, and it grew to be an international company. One of our cars is in Germany now. And much more recently, I did operate the Agile program at Tesla, and I learned a lot, a huge amount. And I'd like to try to share in a short amount of time about 30 minutes worth of what I learned, the hit list, the top takeaways, and then see if there's any comments or questions so I can learn from you and you can direct the conversation. I'll start by sharing my screen. Depending on your layout, the size might be funny, but I'm actually going to make this a little more narrow. I think it'll actually flow better. Hi, I'm Joe Justice. That is my real name. I have an office in Tokyo and an office in Hawaii. I have been a developer at Microsoft and a Scrum Master for Bill Gates. And it's not like I'm cool because I worked with Bill Gates. I mean, if one of you told me you worked with Bill Gates, I'd say, wow, that's cool. And that'd be it. The conversation would be over. Unless I was quick on my feet and I said, what did you learn from Bill Gates? Because now that's something interesting for both of us to continue the conversation. So I'll go right there. What did I learn from Bill Gates? Bill is not an agilist. What Bill does do is what software people, and I was a software person, called object-oriented architecture. And here's what I mean. Everything Bill takes and tries to cut it into as many parallel executable missions as possible. And then he runs them all at once with small teams. That is the entire management style of Microsoft under Bill Gates. And it works awesomely. At sometimes, Bill Gates was the wealthiest person on planet Earth, at sometimes, depending on how it was measured. And that is, in a nutshell, the entire strategy, as far as I could learn. I'm sure Bill tried to teach all of us more things, but that's what I was able to learn from Bill. And every single meeting I started with Bill, he would say, how much of this can we do in parallel? So my one gift to all of us is that. Now, that felt good to me anyway. As a software person, I liked the idea of parallel execution, multi-threading, virtualization, Hyper-V. And that's Bill's trained mind for everything in business. Well, after that, I got to be a consultant to the leadership team at Amazon. And Jeff Bezos also has massive parallel execution in teams. That's not new anymore. And what Bezos added to the mix is the teams are small, about 6 people or less. And the math has been figured out now to a point as to why 6 people or less, with 3 as an ideal, is such a good team size. But what Bezos at least was able to articulate is the teams innovate faster. They're more creative and they innovate faster when there's 6 people or less. So Bezos has more than 3,000 agile teams in Amazon. And it's their job to come up with their new business goal. It's not like Bezos stepped down as CEO, but when Bezos was CEO of Amazon, it's not like they waited on Bezos to come in or some leader to say, here's what you need to do. These agile teams, their job is to figure out what's the most valuable thing they do next. They're these autonomous, largely autonomous, self-organizing little mission teams. And there's 3,000 of them in Amazon. And that makes the speed for which Amazon is famous. Then I got to work at Tesla as a full-time employee. And Musk's entire management style, if I had to sum it up, is speed. Period. If there's 2 suppliers and one costs twice as much, but they deliver in half the time, you go with the supplier that delivers in half the time. There's no question at all. It's speed. Many times for Starship, the largest rocket ever made by humans, the design of Starship was constrained not by what's the best engineering design, but by what materials can be delivered in less than 24 hours. Musk subjugates, he makes lower class the design, the engineering, the business model to speed. It's okay, here's 10 different rockets or 10 different cars, and they're all different levels of awesome. Which one can we make the fastest? Period. And what that does is it makes it really exciting to work there. Every other company I've ever been in as a consultant or worked in as an employee felt like it was moving in slow motion compared to the Musk companies. As a Tesla employee, there's a lot of permeability. You can move back and forth between all the Musk companies. So I went to SpaceX Boca Chica and SpaceX Hawthorne, California. And a SpaceX engineer made the stamped body panels for the first Tesla Model Y. There's play back and forth between all the companies. And it feels lightning fast. And this is what keeps the interest of highly talented engineers. And interestingly, even for engineers of average or low talent, it's so exciting. I think it brings out the best in them or in us. So you have the idea of do everything in parallel. And that's how I will sum up Bill Gates' leadership style. And try not to have these parallel executing pieces have to wait on each other, because then they're not really in parallel, then they're in sequence, right? So part of the gift is trying to view a business problem as parallel executable chunks. Then Bezos tried to get it so that the mission can be completed without waiting on anyone else with 6 people or less. Wow. But it works, it ramps up the innovation. And then Musk is speed over all else. Now, what rescues Musk, especially recently, is automated quality tests. And this is why, according to some quality surveys, Tesla's at the top now. Now, there are some quality surveys that actually have paid results. And then Tesla, it depends on who paid for the survey. But in generalized, not paid by a specific company quality surveys, Tesla is near the top now. They didn't used to be. Well, how? How can a company that prioritizes speed over all else also ramp up quality? That's automated test. I mean, it doesn't matter how fast you change or how short your innovation cycles are or how quickly you introduce new product if you have an automated test for quality and it's accurate. You could change the model every day. And as long as the test shows you is it quality or not? And it's a good test, it's an accurate test, and you only ship what passes the test, your quality will be high. And that's what's rescued Tesla, what's made them so competitive. What I've prepared for us here is an overview of a 2-day class that I teach now. It's called the Agile Hardware Developer. And it's basically what I learned from Tesla. It's how do you make design and production and certification in hardware really quickly. And I'll just give the punchline here. In Tesla, the rate of change is about every 3 hours. About every 3 hours in Tesla, parts come to you, electronics that you have never seen before, every day. And because of that, every car is tested for road legality individually, because potentially every car could be unique. So automated testing is a first-class citizen, and homologation happens for every single car individually, because every car could potentially have a different adhesive, a different shaped ball joint, different electronics chips controlling the airbags and safety critical systems. The only way that's responsible is by doing this. A sprint review in hardware means hardware is fully tested, homologated, certified, and in production. This means every single car and rocket puts itself through automated testing of every non-destructive compliance and certification test. This is called factory mode. And here's a picture of factory mode, and here's a picture of a Tesla Model S putting itself through every non-destructive road legal compliance test. And this is where autopilot came from. So factory mode came first. It was so important that these cars test themselves. That's what Tesla built. And the fact that these cars could avoid a forklift or other cars and stay on the test track, autopilot grew from that as an afterthought. In the class, we view hardware sprint reviews and agile hardware retrospective techniques to increase the speed of the next hardware development cycle. So this is the first key point is, I will say, according to Tesla, speed of innovation is the only thing that matters in the long run. So you want the shortest sprint you can have, 3 hours if you can. Well, how do you make that safe? How do you make that legal? You have to test every product. In a company like Toyota, I also worked in Toyota, and I worked with Nissan, and I've worked with Volkswagen. In those companies, testing is long and expensive. So they don't want to test every vehicle. In fact, they don't want to test very often. So they'll lump changes together every 2.5 to 7 years, depending on the model. And then they'll retest the model. They'll go through homologation again. Well, that means you have a 2.5 to 7 year sprint, because a sprint means product release to customers. That is the definition of a sprint. It's not like you have a planning sprint or a funding sprint. I mean, a sprint means design, analyze, build, test, deploy, and that includes certification. So for Volkswagen, for example, some of the cars are on a 7-year sprint. And for Toyota, some of the cars are on as short as a 2.5 year sprint. That means within that cycle, you don't want any change because you haven't tested. You don't want untested change. That wouldn't be safe. Well, the enabler here is factory mode. Every car puts itself through every automated test in Tesla. So you can introduce change at any time. And you'll know immediately if that new adhesive meets road legal safety criterion and if the car can be homologated for road use. And of course, SpaceX does the same thing. Here's me in front of a Falcon 9 rocket. And there's a video clip that we watch in class of a sprint review at SpaceX where 2 Falcon 9 boosters land themselves simultaneously and automated. And of course, it's automated testing. It's DevOps. It's not like there's a human with a joystick. The rockets land themselves automated. If there was only one thing I shared with everybody here, I want it to be this: the idea that your rate of test determines your safe and quality rate of change. And it is possible to have sprints as short as every 3 hours in something as complex as a car, but that requires awesome automated testing for safety and quality. the next piece is, what about suppliers? I just finished a presentation with Airbus. So I have the head of Airbus's Agile transformation, or part of it, Olivier Messo, here, talking about how Airbus is doomed because they're so slow. Olivier has a great sense of humor. So that is the actual Agile transformation lead for Airbus. And I just disconnected from there. That was like the 1 minute before joining you. In Tesla, hardware in production changes about every 3 hours. That includes hardware provided by some suppliers. In the course, in the 2-day Agile hardware developer training, we have a little more time. So we practice reviewing and writing Agile supplier contracts. I'm happy to share an example with Prowareness, and they can distribute it with you if you like, or you can take the course later if you want to. We then visit the stamping and casting operations virtually in the class in Tesla. Here we share how casting and stamping changes as fast as every 45 minutes. Now, stamping and casting in automotive is typically the longest lead operation. Your die set, your big pieces of metal to press doors into and hoods and stuff like that, that's typically 18 months lead time, sometimes 3 years. You really don't want to change those. And a die set is often millions of euro. Tesla changes die sets every 45 minutes. It's that crazy, and it's that awesome. When your rate of change is that fast, you get economies of scale even with change, because you get economies of change, and the die sets start to be really cheap. But we'll go through that example. What I want to say here is those castings, those die sets, are delivered by a supplier. That's a highly agile supplier, and they deliver new die sets every 45 minutes. This is a public example now. It's been on Sandy Monroe Live, who's an engineer that tears down cars, showing how the rear third of the Model Y was replaced from this to this in 45 minutes. I was in Tesla when that happened. And depending on where the Q&A goes, I can tell that story in more detail. So here we share how casting and stamping changes as fast as every 45 minutes with support from agile suppliers and amazing technology like the Mega and Giga casting systems. The Mega and Giga casting systems are made in Italy. So that's actually EU equipment. Tesla is the one who crams new dies in them every 45 minutes. Here's an excerpt from an actual contract I was asked to sign from an EU company. The vendor must ensure that written notice is received at least 9 months before the effective date of the scheduled date of the implementation of any changes. That contract means the absolute shortest sprint you could possibly have is 9 months. I mean, it's probably a lot longer than that because that's just to receive that part from the supplier. But that means no matter how fast the rest of the operations are, the sprint length, the rate of change and release is 9 months minimum. So you can't have a contract like that in a company like Tesla. So the way the contracts are written is incredibly important so that they're legal and they're fast. So I show how Tesla does that in the class. And then Olivier Missot actually said to this huge group of Airbus employees just 22 minutes ago, even Tesla's suppliers can deliver in 45 minutes. What are we even doing? Our contracts are like tying weights onto a high jumper. This is a train wreck. Save our jobs. Now, Olivier, I think, was having a lot of fun with this. I don't think it's that bad. But Olivier was also stressing the point that, yeah, even suppliers can be fast. So that's not the excuse, right? It does mean contracts change. And it does mean even some laws are updated. But that's what Tesla Giga Berlin is doing right now in the EU. So maybe some of your companies can also lobby for some of the law changes. Tesla's doing it. And already some more agile contracts are fully allowed now in the current law. With that, may be a good time for a little levity. At the end of day 1 in the class, we have happy hour. And people take the courses from all over the world. So I don't know what time it is for everybody when they take the course, but I say it's fine to have a beer. And a lot of people do. And for a lot of people, it is the end of their day. and they have a beer or a wine on the virtual classroom. And what's important about this, I think, is we just talk casually at the end of class for another 20 minutes, and people actually make friends. And I think this is necessary when you're talking about a change as big as new parts in every 3 hours, or in some cases every 45 minutes. Agile is a game. It is. When I teach Agile, I use a game board, and we move game pieces down to go through the 5 events and 1 activity of one of the more popular Agile methods. It's a game, and we play it at work. It should be fun, relaxing, and it should make friends. It also happens to be the fastest way to innovate and produce. So let's play it. If your Agile feels like some top-down commanded bureaucratic thing, we're probably playing the game wrong. I mean, there's ways to play a lot of games that are high stress, but there's ways to play a lot of games that are just as fast or even faster, and they're relaxing and fun and make friends. And I think that's necessary when you're going this fast, especially in Tesla. Tesla famously used to have a very high burnout rate. There still is a decent burnout rate, but it's much better now. And part of why is because Elon focuses on playfulness. Giga Berlin opened with a rave. The SpaceX launch tower in Boca Chica, Texas, has a bar on the top of it. And not even just any bar, it's a tiki bar. It's a Polynesian themed bar with grass skirts and scary carved wooden masks and pineapple drinks with strong alcohol in them. That's on top of the launch tower. Like, playfulness is built in, and the level of it just keeps getting higher and higher. Musk changed Musk's title. Musk isn't the CEO of Tesla anymore. He's the techno king, the techno king of Tesla. And I think that's actually required when the work is this fast, when it is that intense. I think that's what helps slow the burnout rate down or even prevent it. Okay, I've been going for 25 minutes now. I was thinking 30, but this was a pretty playful point. I'll zoom out now to the entire factory. And this is Fremont, California, what we call the mothership. And that's where I spent most of my time working. And I'll stop share for the moment so we can see each other more easily. And I'd like to see if there's any comments or questions. And if it happens to be something that the factory floor plan shows better, I'll zoom in and share the screen again. Otherwise, we'll just talk. So please feel free to tell me what's important to you or ask me if there's something you want to know.
Joe, I'm not sure whether the chat has been used. Sometimes people already type into the chat. That would be a way to do. I do have one question prepared for you, because there is growth. There's people coming into the company very easily, so you can't uptrain everybody. And I've heard you already explain that there's a concept called walk up simple to task, which is really built on DOR and DOD. Could you elaborate a little bit on that? And I was really curious, who makes the DOR, DOD? How does it emerge?
Perfect word choice. Perfect word choice. Thank you so much. When you come into Tesla every workday, you get to choose what you want to work on. You use something called the law of 2 feet. If any of you have ever been to an Agile conference ran with open space, that's what essentially replaced the PMO, the project management organization at Tesla. So if you've ever been to an open space conference, there's an agenda, and it'll say something like whether the conference is online in Zoom like we are, or whether it's in a physical conference building, there'll be an agenda, and it'll say, starting at 9 o'clock in this room, there's someone to ask questions on this topic. They don't even know the answer. So show up if you have some answers, because they want to learn about it. And it's okay, you can go to that room if you want to be part of that conversation. There's at least one person there, and they don't even know about the topic. They want to ask about the topic. Then they'll say, at 9 o'clock in this other room, there's someone who's the expert on this topic. And you can go there if you want to listen to them or even ask them questions. And then this other room at 9 o'clock, there's no agenda yet. So you can propose anything you want, and it goes on the agenda list, and see if anyone shows up. If no one shows up, it wasn't a good topic. If a lot of people show up, it was probably a good topic. So you can choose when there's empty spaces. And then at 10 o'clock, 11 o'clock, there's different sessions throughout the day. That's what it's like showing up at Tesla. So on your phone, there's a set of apps that show you, here's the possible projects for today. And all across all the physical sites, there's these huge monitors, and you can log in, encrypted on your laptop too, if you want, and see what they are. And you can propose them also. And it'll be things like, we think it's physically possible to get 2 more kilowatt hours of energy into the pack on the Model Y. According to the laws of physics, it's possible. We don't know how, but it should be possible. If you're interested in trying to figure that out, here's where that's happening. Show up and use what's called the law of 2 feet and go there. So that's the first part. It keeps the organization nearly 100% flat, because it's not like your boss tells you what to do. It's not like you have some career path you need to prove, right? You just try to solve problems as fast and with as high quality as you can. And that's really exciting for engineers. They like to work that way. And Tesla, by the way, is worth more than $1 trillion US now. And in fact, it's enough over $1 trillion. I think it's worth right about €1 trillion now, even. So it works. There's something about this that's working, is what I'm saying. It's not like this is some pretend play company. Then there's the idea of walk up simple. So use the law of 2 feet. You finish something. Yeah, I mean, it's not like you leave a project in the middle. That'd be bad for morale and bad for the project. So whenever you finish something, you then look at the agenda and use the law of 2 feet to decide where you're going to go next. Well, how do you contribute quickly? That's this concept called walk up simple. And the idea is, in the shortest amount of time responsible, to allow people to be able to contribute in a meaningful way. So there's signs. Often, if it's physical, they're like blue tape with marker written on them saying, over here is this thing, and over here is this machine, and here's a test bench that we're setting up, and here's the current battery cells, and here's a batch of battery cells with this different paste inside, but we don't know which is better yet. And so you have these quick to write tags. And then sometimes they're like printer paper taped up, just standard dimension printer paper with some information. A lot of the time they're pictures on whiteboards with a date, a time, and a signature and contact information. The idea is the shortest amount of time for you to be able to contribute. And that goal is walk up simple. And who makes the walk up simplicity is anyone. Especially if you were contributing, you've probably learned something. So you try to update that. What enforces it is Tesla has overlapping 24-hour shifts. Now, Tesla gets criticism for this, maybe rightly so. They're 12-hour shifts. So I worked 12-hour shifts when I was there. The good part about 12-hour shifts is you have a 3-day or a 4-day weekend every week. You work either 3 days and then you have 4 days off, or you work 4 days and you have 3 days off. The other good thing is you get really good at walk up simple, because when your shift ends, no matter what you were doing, I was operating the Agile program, but whatever you're doing, you hand off to someone else. And when you come in the next day, you get something different than you left. So the idea that there's shared ownership is immediate and impossible to not notice. And the opportunity to check your walk-up simplicity is tested every day, every single day. And then you have it fed to you when you come back in. Is the walk-up simple still clear, right? Can you understand the current state? And that has everything to do with an Agile team working agreement and a definition of ready and a definition of done. And as the operator of Agile at Tesla, that's actually what I spent most of my time on, is definition of ready and definition of done. For this group, is there a clear label? Is there an API to the rest of the company for what they need? What parts come in, what CAD comes in, what supplier contracts come in, how much money needs to come in? And then is there a clear, at least for today, definition of what needs to come out and its quality bar, its definition of done? Now, Tesla made massive investments in machine learning years ago and then has continued to. By this point, the machine learning is really good. There's awesome machine learning stack in Tesla. So often the definition of ready and definition of done is automated. There's a camera and there's processing in the cloud and on laptops, and it looks at parts coming in, people coming in, also tracking finance and data to see is the definition of ready being met. And you get a heat map. Basically, it ends up being like a red light, green light. But what it really is a heat map. And you can see, is there more green? Is there more red? Is there more purple on stuff or assets or data? That tells you is your definition of ready being met. And same for the definition of done, which is a corresponding definition of ready for either the end customer, if you're delivering a completed product, or the other assemblies you're going to integrate with.
Thanks, Joe. I see a question coming in from Bas, or at least I see lots of questions coming in. But let's start with the question from Bas. Bas, would you like to explain your question?
Of course. Now that I have the floor anyway, Joe, you gave a shout out to ASML, so let me return the favor. Because I was there when you were in Den Bosch, I think about a year ago. And we're still using some of the information that you shared during that session also to inspire the people in ASML. So it was a job well done. I have a question. I remember on a slide that you showed. Nice. I remember on one slide that you showed about suppliers, and that Tesla or SpaceX, one of the two, uses Agile suppliers. So I was thinking, are there any other type of suppliers that are used to do business with? And if so, how do you collaborate then to deliver according to the speed that Tesla or SpaceX needs?
Brilliant, brilliant. Well, I mean, there are almost zero native Agile suppliers who are already Agile. So what do you do? And here's what Tesla was doing when I was there. For those dies, those big pieces of metal to stamp hoods and eventually to make the entire third of a car as a casting. So huge die sets. That supplier is actually from the same home state near where I was born, that farming area called Indiana. That's where that company is, that supplier. So it was easy for me to talk to that supplier. And we shared this story together. They said Tesla signed a contract to have a new die set delivered once a year, which is super unusual. I mean, usually you do one die set per product and you're done, for 7 years or more. But Tesla said, we want a new die set once a year. Will you agree? And this company's been making die sets for a long time. And they said, well, yeah, we can. If you'll pay that much, we can. And in fact, you'll get a discount if it's one a year, but it's still a lot of money. But yeah, we'll do it. So that's already a little bit Agile. That's a 1 year sprint length, and the supplier could process that, right? Well, that actually worked out okay for a little while. So then Tesla updated the contract, said, we'd like a new die once a month. And the supplier said, whoa, if you want that, we'd need a team dedicated only to you. And we wouldn't be able to interrupt them with anybody else's work, because then it would slow down your work. And in fact, we then need to designate part of our operations only for Tesla. So it's always in progress. And essentially we'll never finish design. Like by the time design finishes, one's being machined, we'll already be designing the next. So the design phase will never end. And the Tesla folks are like, yeah. And they said, okay, we'll do it. And they delivered a die set once a month, which was a massive change for that supplier. Well, that started working okay. And Tesla said, okay, we'd now like a new die set once a week. And the supplier said, you're nuts. If you want a die set once a week, we'll have to go to your factory. And we'll need to set up our operations inside your factory. And we'll need to machine our dies in your factory so we can load them into your machine if you want us to be done in a week. And that's when I met them. They said yes, and they came into Tesla, and they had set up their shop inside Tesla, and that's exactly what they were doing. Now, once they got there, they found that by machining constantly and updating CAD as they're machining, and then taking the dies directly out of the mills, the big mills that are making these massive metal parts, and putting them into the casting machines, they could actually get it down to once a day, and then eventually with more milling machines and stronger milling machines every 45 minutes. So it was the contract that drove it, and they started with a cadence that was a little shorter than the supplier was used to, but something that fit the supplier's current cadence, which was a year.
Joe,
All
can I build on that story? Why do you need all those adapted? Sorry, my name is Arjan de Winter. I'm a colleague of Bas. I used to work in the automotive in DICE. I'm very interested. So it's fascinating. Why do you need every 45 minutes a different die? What do you use them for?
Okay, yeah. This is one of my favorite stories because I actually get to say it. There's a lot of what I saw and did and took photos and videos of that I'm not allowed to share yet. They're under my NDA. This was shared publicly somewhere else, and I got to be there when it happened. So I'll share. In this contracts part, or introduce the idea of the contracts, almost every car in the world is made this way out of stamped panels. In fact, in a parking lot outside, every car in that parking lot is made this way out of many different stamped panels that are then welded, riveted, glued, or all three together. That's how these bodies of cars are made. What you wish you could do is make them like Play-Doh, like a toy car. You pour melted metal into a casting and make it in one piece. It's safer, it's lighter, it's cheaper, it's faster. You wish you could make cars like you make toys, but you can't. Because when you have something as big as a car and you pour or inject molten metal into it, you can't get the metal into it fast enough to avoid bubbles forming as it's cooling. And with a random distribution of bubbles, a part that big isn't safe for a car. So you can't make a fast casting. I mean, if you filled it super slowly in layers, you could, right? But for quick production, you can't cast a car that big. And I'm working on the line with a team, and we're doing our steps and adding our value and doing our innovation on the line. And these Model Ys are coming by, and they look like this, like every car that has ever been made on planet Earth. And then one comes by, and that's actually the front. Do I have a picture of the rear? Yeah. And the rear third of the car looks like this. The rear third of a car is a casting. That's what you wish you could do. You can't. It's not safe. There's bubbles, or there would be. How is this possible? Our definition, I've never seen this before. No one told me this was coming. The definition of ready light goes green. And my team and I look at each other and we do our steps work, and the definition of done light turns green and it flows by. Now, just because that worked and it was safe, that car was sold, doesn't mean it's ideal. 45 minutes later, there was a different casting, different designs. It was slightly safer, slightly cheaper, slightly faster to cast. 45 minutes later, again, slightly cheaper, slightly faster. And for those of you who attended Giga Berlin's opening about a month ago, or attended it online virtually, you may have seen that Giga Berlin now uses a casting for the entire front third of the car. The casting I saw, or all the versions of it, for the rear third of the car. And in the middle is only the battery pack, which is now the structural floor of the chassis. This makes it cheaper to make a Model Y than any other type of car in production by a large margin. Now, by iterating, you can keep making it cheaper and safer and cheaper and safer, and keep making room for all the other components that are changing every 45 minutes. The net value isn't just cheaper and safer, it's innovation. And Tesla's strategy is pace of innovation is only thing that matters in the long run. So you never want to tell an engineer to wait. They lose the idea, they get frustrated, they quit, they go work somewhere else or start their own company. And by telling an engineer, okay, do it right now. In fact, if you're done in less than 45 minutes, it'll be in the next one. That gets the company so exciting that top talent wants to stay. Whereas in Renault, for example, there are some really good ideas that are going to wait for 7 years or more before they're even tried in production. And so you have what's called cost of delay.
Yeah, interesting. It's fascinating. It's turning around my thinking of the world. How do you then, because I think every 45 minutes you can have another one. At a certain moment, it's good enough. So when do you decide good enough for transfer to production? What's the criteria that you use there?
Awesome point. Awesome point. Everything I'm saying is in production. These cars are sold. There are 2 million Teslas on the road, and they are all potentially unique. These are all in production. This is production. There is not a difference between design and production. But your point still stands. When is it good enough?
Yeah.
Whenever the cost to implement an enhancement is higher than the expected benefit, it gets pushed down the backlog. Now, someone might have a better idea 10 minutes later that is high value, right? And so it jumps back up. That's fine. But an idea doesn't get executed if the guess, and it's quick guess, like 10-minute or less guess of the estimate of a project is guessed to be less than the benefit to the company over the length of the innovation.
Thanks.
Sure. Oh, but it's not only cost, because there's also value in continuous learning and in risk reduction. So some projects that actually the customer wouldn't care are executed because the company learns a new skill. Oh, we get to use this new material and it's not any worse than the current one. Let's do it because it's important. We think this new material is going to be strategic, so it'll get prioritized. Another is it will reduce risk. It actually costs more, but it adds something useful in this area. So value is money, risk reduction, and capability building. But again, this is a short estimate. It's like a planning group goes off site for a month. It's like a 10-minute guess.
Thanks.
Great, thank you. I see the next question is from Laurens. Laurens, can you repeat your question? That wasn't the question. Laurens, are you
I'm
there?
sorry. Yes, of course I'm here. Yeah, I put it in the chat. Well, it's a really fascinating story. I'm from the government, so I'm from this bureaucratic organizations you like so much. And we are not yet that fast, of course. But my question is, how are the customers or the clients or the buyers of these Teslas, how are they involved in this production change? Is there any feedback loop, or how do you measure their input, and how do you put this input into your sprints?
There's a good and a bad here, and I'll just be honest and share both. The good is Teslas have really good real-time analytics. For all 2 million Teslas on the road, there's real-time feedback of how fast they're being driven, how fast they're being turned, do they brake aggressively, who's probably driving, how many people are in the car, how heavy is the groceries in the trunk, what kind of music are they listening to when they drive slowly, what kind of music are they listening to when they drive fast. I mean, anything Zing knows about you, Tesla knows that about every car. So the analytics help, and they inform a lot of design and production decisions. So that's the good part. The analytics are excellent, and they're automatic, and they're for every car. Here's the bad part. When I was operating Agile at Tesla, which is customer-centered design, there is extremely little customer input and extremely little customer involvement. And I actually think that's an opportunity. I think if Prowareness got to consult to Tesla, I think they could help a lot. So there's some practices in the Agile canon that Tesla is missing that could help. And I think the customer involvement, customer-centered design, customer feedback is an opportunity. The analytics are really good, but I think the other aspects of customer involvement from agility are an opportunity.
Okay, thank you.
Great.
Absolutely, Lauren.
I see 4 more questions, so let's see if we can all get to them. Kees?
Hi, Joe. Your story triggers a lot of questions to me, actually, also on the production environment and the variety of Teslas and warranty and all that kind of stuff. But I had actually another question that was about the how do you measure the individual contribution of people in the organization? Because you said you step in and you pick some work and then you hand over after a couple of hours or days. How do you measure the performance of people in Tesla?
Wow. Okay. I assume I should just simply be honest.
Not.
Yeah, I wish I could say something really clever, but okay, the performance is measured per project, and projects or teams, because teams and projects are essentially the same thing. I mean, you work on one thing at once until it's done, you know, with a group, and then you choose the next thing. Projects, you have real-time data that everyone can see of your rate of resource consumption. So how much money does it take to run that team for a unit of time or that project, including buying stuff, software licenses, lunch bills, I mean, whatever you would have, right? That's largely automated. It's not perfect, but you have a number that's a pretty good number of the cost to run this team or this project. And then there's an estimate of the value to the company that that team has made, and only once it delivers it. So there's no in progress value, right? So that also helps focus on trying to deliver something frequently and early, you know, to make that metric look good. And that's CapEx, capital expenditure, and OpEx, operational expenditure efficiency, is what those numbers are called. So money coming in versus value to the company, and it's a percent. And your team's job is to increase that percent. You're making something valuable to the company versus the cost to make that valuable thing. So projects are measured by OpEx and CapEx efficiency almost exclusively. I mean, that is your value, and everyone can see it for everybody. And it's not like at a personal level, it's at a project or product level. Then how do you measure people performance? I'll just be honest. You don't. No one cares. Really. And here's why. This is, I'm not saying every company needs to run this way, but this is what Tesla does. Everyone in the company makes right about the same amount of money, and it's very little money. Everybody, it's an experiment in universal basic income. Everybody makes right about $20 an hour. Everybody. Doesn't matter how cool you are, what you did, if you were just hired, if you were hired to clean the floor, or if you were hired to be head of something amazing, because there is not really, once you're hired, everyone does the same thing. You all use the law of 2 feet. Now, Tesla externally hires for certain positions to attract talent and skill. But when you're in Tesla, then you're employee. You just go. And it doesn't matter what your title was when you're hired. And you're paid about the same. So how does that work? Why would anybody work there? That's not even a living wage, barely, in the Bay Area in California. How does that even work? You have an awesome stock price package. The detail of it is you can buy stock at any time as a Tesla employee for 25% less than the lowest price the stock has been that quarter. Well, in a quarter, Tesla stock has doubled value, and you get it 25% under that. So most of the people well, I don't know about most, many of the people you're working with are millionaires, many of them. And they're working there not because they're saving up for retirement. They could retire anytime. They're working there because they actually love the work. It's satisfying, fast engineering, and because they like the mission. So by sharing company value through stock, in this case, and having universal basic income, essentially, no one cares. There is no career path. It's not like you're a level 2 anything. No one cares. You just use the law of 2 feet and try to increase OpEx and CapEx efficiency and have as much fun as possible. You're already a millionaire.
Thank you.
Now, how that would translate to another company is a whole other topic. I try to give a sincere answer to that in my book. Like, here's what maybe other companies could try, but that is what Tesla does.
I'm working at an insurance company. It's slightly different.
Well, maybe it's at least exciting to think about, or it could be experimented with in a small group.
Let's experiment. Let us know how it goes. Thank you. Petra.
Yeah, hi Joe. Yeah, question from me. We're not that young as a company. Like Toyota, I think we are more than 100 years old. And we make steel, Joe, and it's something being used by Tesla as well. So what you have seen Toyota. So what can be the first steps in a company not being built in a digital era, but in a steel era. Yeah, what can be the first steps to take? Because there is so much to do in bigger companies with a lot of legacy.
Oh, I love it. I love it. I love it. Well, I guess that is what would be called an agile transformation, and where to start. First, to give you an opportunity to go deeper, chapter 16 of the book, Scrum Master by Joe Justice, is on everything I think I've learned about that, about switching from a company with legacy, maybe even a lot of legacy, towards, and even eventually all the way to, if you want, what Tesla is doing. So that's chapter 16. It's called Switch. And it's everything I think I've learned about that. So you can go deeper if you want to with that book. Then to say it, so you have something right now, whether you ever like to read the book or not. Toyota still tracks a lot of products on paper. And that made sense at the time. And at Toyota's current speed, it still makes sense actually, but that's the problem. So this is what we would call digitalization. How do you replace the paper and not have the same number of manual steps? The advantage of digitalization is then it's relatively easy or possible to start automating, to begin automation steps. So in Toyota, they can't go faster than the speed at which they file and check and recheck paper. There's other issues as well, but that's one. And that's a pretty clear way to start. And it starts introducing the idea of the speed of software being able to be the new bottleneck. So a digitalization opportunity to eradicate paper bit by bit as responsible. Some places you're legally still going to have a file somewhere, but a lot of operations you don't. Or a picture of the paper and shred the paper can work in some cases. And then automate the collection of it can eliminate that bottleneck. So I'd say a digitalization initiative, bit by bit, forever, and I'm sure you're on one.
I saw also something, sorry, Joe, you also have to build new factories, for example, to be better for the environment, etc., etc. I saw a great example of how Tesla did it. So did you advise something as well for Toyota or legacy companies to have another strategy on that as well? So for new facilities, this is just one of the best pictures I have, so it'd be silly not to share it. Here on the Model 3 line. This is Tesla Giga Austin, this land, the day they bought the land. The day Tesla bought the land, they cleared and leveled it that day. This picture was taken 90 days later. So how did they do it? Oh, and by the way, you can see the building is under construction. This is a zoom in. They're actually already manufacturing cars while they're constructing the building. So how? What? Well, you can see the building is a repeating set of modular structures. It's modular architecture, like good software would be. They're kitted here, and each module can be different. They learn as they go, as long as it's compatible with the other modules, as long as the connection points stay the same. Then each module gets its own power through solar. It's also grid tied, but it has its own solar and it has its own plumbing. So each of these modules, from the moment they're finished, they start operating inside, so they get feedback, they get learning. So if it comes to construction, I'd recommend that. Then ultimately, the recipe for speed is something I'm so proud of. I actually did name it after myself. Maybe that's vain, but I'm really, really proud of this. And I don't know if it's really the way to start, but when it comes time to restructure, which at some point every company restructures, when it comes time to restructure, you can unlock a lot of speed. This is where a lot of Tesla speed comes from, and I'm so proud of it. I call it Justice's Law. And Justice's Law is the modules of the system define the structure of the company. Or put more simply, the modules of the product define the structure of the company. So for Tesla,
It's not like they have a closures team for the way the doors and hood close and a quality assurance team. That would be a skills group, and you'd have queues in front of them. Instead, they're independent parallel executing teams, like what Bill Gates tried to teach me. So this isn't new to Tesla, but Tesla does it. Tesla is structured according to Justice's law. So you have a battery pack group, and that's the structure of the company. Whereas if you had a procurement group, every team would have a queue in front of procurement. So that means the battery pack team does have their own procurement. So they don't have a wait state. There's not competition for that procurement resource for body in white or the other modules. But this is where the things start getting really fast when you actually do this, Justice's law. But that does require a company restructuring. So
Yeah.
when it's time to restructure, please visit that part. I highly recommend it.
Very
Joe,
nice,
Joe,
thanks. Yeah.
Joe, Rini here. It sounds like Tesla doesn't produce cars. It sounds like Tesla produces factories that, by the
Yes.
way,
Yeah.
produce cars.
There's two cool aspects about that I think we all might enjoy. One is, if we think about the factory as the product, the compiler, you're compiling cars, the compiler of the factory is the product, that shifts focus in a useful way, I think. Then the other is, it makes the factory more beautiful. And I think this is super important. Like, there's really high design in the factory. There's a lot of, like as good as some really nice offices are. And for example, some of you are in the Netherlands right now. Dutch architecture is some of the most interesting and most beautiful architecture in the world. And Dutch design is some of the most interesting and the most beautiful in the world. But unfortunately, a lot of the production facilities don't have it. It's reserved for the offices and boardrooms and really nice bathrooms, which are great. But if the factory is made that way, maybe some of the designers and executives would want to be in the factory more. And there's a lot of high design at the point of production. And that's where you have maximum learning. Unfortunately, I am out of time. It is 2 in the morning, and I promised myself I would try to go back to bed so I'm not useless for my kids tomorrow. I'm very grateful to be here. I didn't get to Nina and Gideon's points, and I'm sure there were more. So I will ask Prowareness, if you want to tweet to @JoeJustice any of these questions or comments or questions that may arise later. I currently have 100% response rate on Twitter, and I'll try to keep that up. Or LinkedIn is also fine, or Zing. If you tag me, I will answer. Word it in a way that you're okay with it being responded to publicly. I mean, you don't have to give yourself or your company away, but it's a public platform. But the advantage of that is you won't only get my answer, you might get some other really thoughtful people's answer, and they might be better than mine. So I'll prefer to do it publicly if you're okay.
Thank you, Joe. Also, on behalf of all the people in this group right now, I really want to thank you for being here and for giving us this inspiring talk. So thank you very much, and look forward to seeing you again.
Thank you, Joe.
You're super kind.